To the waves required practical part 2, that's waves in a solid. So part 1 was the ripple tank. My name is Mr. Pratt, Director of Science.
So using the wave equation, velocity equals frequency times wavelength. We're going to find the velocity. Frequency is easy. We read it straight off there, 23 hertz. So 23 hertz. And if we times that by the wavelength, then we've got this velocity. So let's count how many waves we've got. Starting from there, that's half a wave, one wave, 1.5 waves, 2 waves. So I'm going to measure one wave directly with the meter ruler because it's big enough that I'm not worried about precision particularly. So one wave is 73 centimetres, 0.73 meters. Pin calculator, 23 times 0.73 gives us a velocity of 16.79. I'll make that 3 significant figures, 16.8 meters per second. So that's the velocity of the wave that's travelling along the solid elastic bungee. So what we'll do now is, same again, I'm going to try and get a different wave pattern on there by changing the frequency. Oh, perfect. So what you'll notice now is it goes up, down to the other end. So we're left with just that, which is one wave. So exactly the same as before. Velocity equals frequency times wavelength. This time the frequency is 12 hertz. It's quite good, isn't it? It's about half of it was before. So 12 hertz. Let's measure the total length because all of that is one wavelength. Well, it should be double what I just did a minute ago. Right, what I'm going to do instead, I'm going to measure along the bench. It's slightly more accurate. That's 1 meter. £1.49 I make it. So 12 times 1.49. 12 times 1.49. 17.9 meters per second. Very similar to before. It should have been exactly the same as before because the speed along that elastic bungee should be the same. So all you've got to do, use the wave equation, measure the frequency straight off the signal generator, measure the wavelength, being careful that you know how many waves you've got when you measure it. Now, one thing that they did do on last year's exam, they asked how you would carry out a practical to investigate how the tension of this bungee affects the velocity. So all you would do is at this end, just put that there for now, you can get a set of weights and you can, by changing the weights that you've got, you can change the tension. What I've got there, I've got that tighter. I can tell it's tighter because I've squashed it into a smaller space. If I just look at what we've got now, you'll see that with the same frequency as I had before, I've got a different number. I've got roundabout, exactly. I'm trying to get 1.5 waves on there. Now that's back on 1. Oh, that's exactly half a wave I've got there. There's one wave, and that one wave now is at a higher frequency, and that's because I've increased the tension. That's quite visible. While we're having a play, let's carry on a bit more. 1.5 waves, 2 waves, 2.5 waves, 3 waves before I take off. I'll let you do the counting. going a bit, increasing the frequency. So as it increases the frequency, the wavelength has to get smaller in order for the velocity to stay the same. I can just about get one more there. Let's do it one count and then we'll finish there. One wave, 2, 3, 4, 5, 6, 7. I make it about 8.
Okay, just to summarise and help me to get some numbers down. So I've got a screenshot there of one wavelength from the first bit that I did. Meter ruler across the top. So the first thing that you do is record the frequency from the generator. So on that one it was 23 Hertz, 23 vibrations per second. Then you measure the wavelength of one wave. Now that photograph there, that screenshot, shows one wave. So it's the distance from there to there. So we've got the wavelength there, which is 0.73 meters. Now we use the wave equation, calculate the velocity. So the velocity is 23 Hertz times 0.73 meters, so that gives 16.8 meters per second. So that's the velocity of the wave along the bungee. So then if we go to a different setup, before we change the tension, we should get the same velocity. So there, I couldn't manage to get the screenshot showing the wave going up and down, but that there is one wavelength. So again, we record the frequency from the generator, and that time it was 12 Hertz. We measure the wavelength of one wave. So we've got it from there to there, 1.49 meters. I've written that down to 3 significant figures. We've only measured to the nearest centimetre there. And then finally use the wave equation to calculate the velocity, and we got 17.9. So pretty similar. So we can find the same answer, the same velocity, using 2 different wave patterns on there. And then finally, by changing the tension, by adding weights, you will find that that velocity changes as you change the tension.